everybody. Coming to you with a little bit of a word problem, a stated problem. And we're here today to show you that consecutive perfect squares must differ by an odd number. Now let's take a look here. I've done a list here of the first few. Right here, perfect squares, 1 squared is 1, 2 squared is 4. And so you can see right here that 4 minus 1 equals to 3, right? 3 is certainly an odd number, all right? Now what's the next one? 9 minus 4? 9 minus 4 equals to 5. Definitely an odd number, right? And also 16 minus 9 would be equal to 7, right? So 4 minus 1 is equal to 3, 9 minus 4 is equal to 5. And I can write down 16 minus 9. These are consecutive. This is the difference of consecutive perfect squares. So that's equal to 7, right? Okay. So we got a strong indication just from the first few examples that that the difference between consecutive perfect squares is an odd number. Odd, odd, odd. There's something odd about this. Okay. Now, so let's explore this a little further. This does not constitute a proof, just some overwhelming evidence that it's probably true. So let's clear all this out here if we can. Okay, I'm going to erase this, folks, and then we'll go on to the next page here. All right. Now, so couple of ideas here, and this all of a sudden we're switching from the realm of arithmetic to actual algebra here. So we've seen a pattern here. Now this would be the form of consecutive squares, right? K squared, then the next one down would be k minus 1 squared. The minus sign right here, of course, would represent the difference, right? Now something that's a common, what they call identity in algebra. This is the difference of 2 terms squared. Now, when you expand this out, the temptation is just to say it's always a squared plus b squared, but actually ab minus ab happens twice. That explains this, okay? Now, I'll leave it to you guys to expand that out if you haven't seen it, but this is quite useful here because look, when we take the difference here, we expand out this piece right here according to this formula right up here, right? What you get is k squared minus 2k plus 1. You can see where everything falls in, the minus and the 2 and so on, okay? But when you actually subtract these off, notice that the k squares go away, and then the minus 2k becomes a plus 2k, and then you got minus 1 here. Well, any odd number is an even number minus 1, right? Any odd number is an even number minus 1. So let's look at an example here. If we chose k equal to 11, we get 11 squared minus 10 squared, and we're just trusting this result right here. So we're going to say 2 times 11 minus 1. All right, well, that's 22 minus 1 is 21. Now you can do the computation here, of course, but notice it's kind of interesting to see you get the same thing. And this does constitute an incontrovertible proof that the difference between consecutive perfect squares is an odd number. Hope you guys enjoyed that.